All right, good evening. Welcome to this week's live training session presented by Unity Technologies. My name is Adam Buckner. I'm one of the presenters here at Unity. This is part 2 of creating an Angry Bird style game with 2D physics. We started off with part 1 a few weeks ago, and we looked primarily at launching the projectile. So let's take a look at the game that we're making. So the game that we're making is over here. So I'm going to go ahead and hit play. And so there's our rock, there's our rubber band, and there's our absolutely essential forked slingshot. We give that a launch, and pow! You can see the camera is tracking our rock, and then the game automatically resets itself. And it continues and infinitely plays this this level over and over and over again. So that's the game we're making. So let's recap how far we've gotten. I'm going to do that by changing projects. So let's go ahead and open a new project. Let's open the project we were working on the other week, which is Angry Meteor. Okay, we do have the sky. We've turned the sky background off so that we could take a look at some of the details. And so in our game so far, we have our main camera, which is looking down on our game. It's an orthographic camera with an orthographic size of 10. We have our sky background, which is a simple sprite. Then we've got a parent game object, and that parent game object has our grass sprites inside, and these are creating our ground. On our ground, we have an edge collider. And so if we we zoom in here, that's on our parent game object with the grass objects on the inside. Then we have our catapult, and our catapult is made up of 2 sprites, the back fork and the front fork, and then we have our asteroid. And if we look carefully at the graphic that our sprites come from for our catapult sprite, we had cut it apart in the Sprite Editor. So we've got one image that we have then turned into 2 sprites using our Sprite Editor. There's not a lot of code. Not a lot of code in our game. Go ahead and bring that back. If we look in our scripts folder, we have just one script at this point. And this is the script for projectile dragging. And this is the one that the main bulk of that script that we have worked on in the past. So now we're going to be building some new scripts. When we're playing the current game, the ball just flies off and disappears. So the things that we need to do at this point to finish our game is we need to set up the camera so that it follows our rock. And we don't want to have that camera continue all the way across the board. When we reach a certain point, we want to limit where the camera will go, and the camera will stop, and the rock will continue on, essentially when it leaves the gameplay area. We then want to do some code for resetting the game. We want to automatically reset the game in certain situations. Then we were going to build some defensive structures, and then do some finish and polish. So setting up the camera, we've got our main camera, orthographic size of 10. So let's write a script to control its movement in the game, so it will follow the rock until it reaches the end of the play area, and then if the rock is still going, it will let our projectile leave that play area. So let's create a new script. So we can add component, new script, and then let's add, let's call it projectile follow. So remember, this dumps it onto the root, so let's go ahead and file that in scripts. And then I'm going to double-click it to load that into MonoDevelop. So we have our new script, projectile follow, and we want it to follow the projectile, grab the camera, and move it with the projectile. So we're going to need some references. First of all, I'm going to clear out some of this extra code, which we don't need. And our references are going to be a public transform, which is the projectile that we're going to follow. How's that? And then we want a public transform. And this is going to be our far left marker and another public transform. And this is going to be our far right. We now have our references to the object we're going to follow. We have our references to an object that's going to define the far left and the far right of our game area. So the first thing we want to do is store the position of the camera in update. So this is vector 3. And that's going to be new position. And that's going to be equal to our transform position. And then we want to set the X value of this stored position, of our current position, to that of the projectile. So we want our new position dot x, and that's going to be equal to our projectiles position dot x. And then we want to clamp the value, that x value that's stored between our left and right bounds. So our new position dot x, and we're going to use mathf. Definitely worth looking if you haven't seen it, what mathf is. Mathf.clamp, and we're going to clamp new position x, and we're going to clamp it between our far left dot position dot x and our far right position dot x. And then finally, we're going to throw it all back together again and say our transform position. Remember, this is attached to the camera, so we're saying the camera's transform position is going to be equal to our new position. So essentially, we create a new vector 3 to hold our current position, and then we modify the x position because we only want to move the x. If we were, say, taking the whole camera and trying to track the meteor exactly, it would go up and go down along with the trajectory of the projectile, and we don't want to do that. We simply want it to move along the x position. So we take our current position, we change the x position to be equal to the projectile, and then we feed it back to the camera. So we take this, let's save this and come back to Unity, clean up my hierarchy a little bit. We can see there's our main camera, and we have slots for the projectile, the far left and the far right. So we're going to need two objects to define our edges. So let's create a new game object, and let's call this new game object boundary markers. And inside boundary markers, we're going to create two new game objects, and they are going to be our left and right markers. So let's just call this one left marker. Now, since they're going to be, this is going to be a parent game object, let's go ahead and reset the transform, and then place the left marker into that transform. And currently, the camera is set at 0, 0, and this is where we're looking at our scene. So the camera's left marker, which is where we are right now, is fine there at 0, 0. So let's go ahead and reset that as well. Now I'm going to duplicate the left marker, and I'm going to make this the right marker. So that's my right marker. So let's place this somewhere. I don't know, about down the X somewhere. Now we can see that up here, there's our marker. We can also do something to make these a little bit more visible. We can grab, do you see this little cube up here? This is icons. So we can give us little symbols to see in the scene. So here's my left and right marker. Let's go ahead and grab that right marker. Let's move it out, I don't know, 25 units along the X. Now, this tells us that our game area is stretching. And we can't see everything we want to see here. Hold on, let me just zoom out. So we're going to need to stretch out both our ground and our sky. So let's grab that sky first and stretch it out a little bit. And hold down the Shift key. We can change the size of the object, of our sprite, but when we're, if we just grab it and move it, it's going to scale proportionally. But if I hold down the Shift key, I can just drag that out a little ways. Scale 1.5. How about that? We also are going to need some more ground, so let's grab that and duplicate that. And hold down the V key. Remember, the V key is our vertex snapping key. So we can grab that, hold down the V key, and we can snap that to the next one. Duplicate, hold down the V key, snap. So we'll see if that's enough. That may be enough, just stretching it out a little bit and adding some more ground. Save that. And let's go ahead and populate these references to the main camera. So we want to reference the asteroid for our projectile, and then our left marker into far left, and our right marker into far right. So let's save that, and let's test. So hopefully this will work. Whoa, look at that. Okay, we haven't given us, our ground is working fine. Our sky needs to go a little bit further over. So let's quit play mode there. And let's go ahead and let's just drag that over our sky. we can come up to the point where that gives we're already lined up on our left. So let's see if that's good on our right. So let's hit play and then launch that. That looks good. So now we're following the ball, following our projectile as it leaves the game. But the game keeps on playing, and that projectile is flying off into the void. We'd have to stop the game each time and replay it. So let's do something automatically in the game. Let's have the game automatically reset itself. To do this, I want to create an empty game object and put a collider around it to act as a boundary. So again, let's create a new game object. There's our new game object, and let's name this boundary. Let's add a box collider to it. Oops, let's clear that. So we'll find that under Physics 2D, Box Collider 2D. And we want to make sure that we're staying inside our 2D components. We want to have a Box Collider 2D so that we stay in the 2D world here. Now, this Box Collider, we want it to be a trigger. We don't want this to be a physical collision. We simply want to detect when the projectile leaves the box. So what we're going to do is we're going to stretch the box out until it surrounds our game area. And when the projectile leaves this box, it triggers some code which we will write to restart our game. So let's go ahead. I'm going to turn off the sky again because I find that nice bright sky is a little bit difficult. So we've got our boundary. We've got our box collider on the boundary. And we can see it's a really tiny little box down there. So let's go ahead and stretch that out by a bunch, back out a little bit, so that it surrounds our play area. Now our play area is now defined between 0 and 25. So let's go ahead and put that that boundary somewhere around, I don't know, 12 or 15. 12 and a half splits the difference. And make that a little bit bigger. And then certainly taller. We're going to need to have that taller. And we may need to lift that up. When the projectile leaves this volume, it'll trigger some code for us. So we have our trigger. There's one thing I need to talk about. In the way that we've worked this code, if we look at our projectile dragging, we're using on mouse up and on mouse down, which doesn't completely respect the rules of 2D. It's made for 3D objects here. So let me go ahead and take a look at this whole setup in 3D. So we now have our collider here on the z-axis of 0, and it is in the same plane that all of the rest of our game plays out on. This is fine for 2D. All of the collisions in the 2D physics engine will take place at that z of 0 on the xy plane. However, when on mouse down is looking at clicking onto the asteroid object, looking at our projectile, it will conflict with this boundary object that we've made that is on the same plane. So if we just go ahead and drag that off, we can see that our box collider is staying at z0, but it will use this z depth when processing whether we're clicking on the background or whether we're clicking on the asteroid. If we left this boundary box with a z depth of 0, then there would be some conflict, some z fighting when we're trying to click on the asteroid game object. So let's go ahead and push our game object off the z plane for our boundary box. The collisions that we want for our game will continue to work fine, but it won't conflict with the on mouse down and on mouse up. So let's go back into 2D mode. So now we need to write some code that works with this boundary. So let's add a new script. That new script is going to be called resetter. And again, it's in C#, and we can see that it's been dumped in the root. So let's put that onto our scripts folder and then open that in MonoDevelop. Now this is going to be an incredibly, well, not an incredibly simple script, a mostly simple script. The core to this script is going to be a function that I'm just going to call reset. So void reset. And simply when we call reset, we're going to ask the application to load a level. What level are we going to call to be loaded? The currently loaded level. So we're going to ask the application to give us the currently loaded level. So how do we call this? Well, the first way I want to be able to call this is if I choose to, if I hold down the R key. And so we're going to look for that in update. I'm going to get rid of the comments here because we all know what they are. So in update, I'm going to say is if my input is the get key down, and that key has the key code of R. And what if we have the key code R? Well, then we want to call reset. So that's the simplest thing. We've now set up a script that anytime the player wants to reset the game, we can just hold down the R key. The next bit of code is, what if we leave that bounding box? So now when the projectile, oops, come back here. When the projectile leaves that box, we want to reset the game automatically. So what we can say, void on trigger exit 2D. And remember, the 2D is important here, otherwise we're going to be calling the 3D physics code. So on trigger exit 2D, and then the on trigger exit will give us optionally the information about the collider that is involved in the trigger message. And again with the 2D, and we're going to call this other. So on trigger exit 2D, we're getting the information from the collider called other, and what we're going to say is if the other's rigid body, come on, rigid body 2D please, is the same as, so we need to define the projectile. So that's up here. So we want a public reference to the rigid body 2D body 2D projectile. So we have this reference to the projectile. So if the other.rigidbody2D is the same as our projectile, then what do? Have we seen this before? We call reset. So now we've got two ways of resetting the game. We do it manually when we hold down the R key, or when the object leaves the game. When it leaves that gameplay area, we reset the game. But what if we don't leave the game? What if the rock stops and just drops and sits there? We wouldn't reset the game. So we need to detect when our projectile has stopped moving. So we can do that very quickly with a public float. Only if I can spell it correctly, a public float called reset speed. And let's give it an initial value of something small, because we want to have this be very small when it's really no longer moving that much visibly. So let's say 0.025 F. Sorry, I'm reading chat. Would you need projectile.rigidbody2D just to compare? There are different ways you could compare this. You could compare it with a tag. But tags take strings and they're a little longer to look up. You could probably do that with any number of different references that you would find possible. You'd want to test which way worked best. I didn't actually write this particular project. This was written by members of the Learn team, and this works. Why they chose the rigid body 2D specifically, I'm not quite sure, but it certainly is better than tag, if that answers the question. So we now have our reset speed. Let's test our speed. So again, if our projectile, if its velocity. Now remember our magnitude question here? This also came up in the last episode in part 1, is that it's much quicker to compare the square magnitude than the magnitude. So really what we want to compare is the projectile's velocity square magnitude. But if we do that, we then need a private value, a private float. And this is going to be our reset speed squared. So we have our reset speed squared, and then in start, we want to say our reset speed square is equal to our reset speed times reset speed. We have our square magnitude now, so we can take if our projectile's velocity square magnitude is less than our reset speed square, then we can reset. But we've got a problem with this. We're looking at the projectile's velocity, but when we're dragging it around, we're going to have this problem where we're dragging it very slowly and suddenly we reset the game because we're simply looking at the projectile's velocity. So we need another way to flag the fact that this is only going to be resetting after we have launched the projectile. And so what are we using right now as our flag that says the projectile has been launched? It's whether or not our spring joint exists. So we're going to need a reference to that as well. So let's take a private reference to our spring joint 2D, and let's just call that our spring. And we need to grab that, and we can do that in start, and say our spring is equal to the projectile, because remember we have a reference to the projectile, And then we want to get component. And what are we getting the component? We're getting spring joint 2D. So we go ahead, we have a private reference to that spring joint, and we grab the spring joint in start because we have a reference to the projectile. And then we need to modify our if, and we need to say if the spring is null and our projectile's velocity, its square magnitude, is less than our reset speed square. And in that case, then we can reset our game. All right, let's save that. So let's come back to Unity and check for errors. Waha, I made it. No red flags. So our boundary needs to have its projectile populated. So let's go ahead and grab the asteroid and put that into our projectile. I'm going to leave the reset speed at 0.025. Let's save that. Let's bring our sky back. We're sort of guessing at where our boundary should be. That seems relatively good. I'm going to turn off maximize on play so we can see where the rock goes. So let's go ahead and hit play. Let's go ahead and pull that back. Boom. And we can see as soon as it leaves the boundary, it resets the game. And as a matter of fact, let me pull this back and hit the R key, and it resets the game. So that's me not letting go of it. That's me resetting the level. So the R key works. Our boundary works. Boop. And now let's see what happens if... is that going to work? Too much velocity. Oh, we forgot to extend our collider. Oh, we were talking about that earlier. There's our ground. Let's take a look at the collider. Hold down the key. Let's drag that out. Oh, let's have a collider for it to bounce on. Oh, we did that in play mode too. Two big bad things. We have to make sure that we're not in play mode when we do that. So let's grab our ground. Let's zoom in, hold down the shift key, and place our edge collider a little bit more closely there. Now, let's save that and play again. A little bit of a jump. Bonk. Okay, you're drifting a long ways. So if we not set up our asteroid correctly, we should have high friction. We should have angular drag. Should be high. That angular drag should be high, like 1. We need to have the angular drag high on our game object so that when it rolls, it slows down quickly. Otherwise, it'll keep rolling for a long time. We want it to slow down very quickly and then reset the game. There we go. Hey, awesome. So you can see how that works. We've got that high friction and that high angular drag, so it doesn't roll very far, and then it slows down enough to get to our threshold. If we didn't have that, it would continue to roll slowly for such a long time we would never be able to reset our game. So I'm going to go ahead and read chat again. There's a difference between angular drag and linear drag. And we want to have very low linear drag. Let's see if I can find it. Come back, asteroid. So our linear drag is very low. So it does slow down a little bit in the air, but not much. The angular drag is very high, so it doesn't roll very far. And we don't want it to keep rolling. We want it to have that resistance. And then also our physics material is very high friction, so it's not going to slip or slide on the grass. So the grass will stop it. It'll begin to roll, but it'll have a high roll resistance, so it'll slow down very quickly. So let's build a structure, our destructive structures. The first thing we need is a target. So let's go to our sprites, and let's take our enemy idle sprite, and let's drag that into the scene. And F for frame selected on the enemy idle sprite. So there you go. There's our target, and let's assign him to the foreground layer. So we want or her, could be a her. Let's assign it to the foreground layer. And it's important to know that these defensive game objects will all have colliders, and they won't overlap because these are going to be proper collision colliders. So there's a point where the colliders are going to keep them from overlapping. So we don't need to worry about order in layer. We do have to worry about our sorting layer. Otherwise, they will collide with each other and we won't be able to see them because all the collisions work on the same plane. But have our little bird here, we don't have to worry about the order in layer as long as he's in the foreground layer. So we want to add a rigid body 2D, physics 2D, rigid body 2D. We also want to get our collider. So let's add a physics 2D, a box collider 2D. Now the box collider is going to be automatically size to the size of the sprite. Now, we could change this manually. Oops, sorry, on the X. Our sky's in the way again, so let's drop that down. Bring in our enemy there. And we can sort of try to size this in manually until we like it. But we got a lot of empty space around our sprite. And there's a little trick for quickly trimming that, the enemy idle sprite. If we make it a multiple sprite and take it into the Sprite Editor, we can trim it. So we can automatically slice that. So that was just slice automatic. We've got our single sprite there, and then we can just simply hit apply. Come back to our enemy sprite, and then we can reset the box collider, and it's going to just pick that smallest space. Now, efficiency-wise, internally, Unity's 2D engine already removes that empty space, those blank pixels. But it keeps that original size because that was the original size we chose to have. So we now have our target. Let's name it target. Oh, I want a capital T on that, please. So let's drag it over in our scene a little bit. Over here somewhere. A little bit farther than the marker. Because we just the same way that the marker is to the catapult. Let's put our target here over on the right-hand side somewhere. And then down a little bit. So frame selected, again, F. And let's put him down in the grass a little bit. There, in the grass. How about that? Now we need some planks to build a house with. So let's grab another parent game object, and let's call this house. And we need to have some planks. There's our plank sprite there. So let's drag that in. And this is going to be very similar. Let's take our house sprite again. We want to. This would be a parent game object, so let's reset that so that it's neutral, and then put our plank sprite in, and back out till we find it. Frame selected. There's our. Let's put it over. We know our bad guy is over there about 30, so let's put it over about 30, and then frame selected again, and then we can just bring it down. It's generally in the same area. We have that same problem with the big extra empty space around the sprite, so I'm going to do the same thing with this one. I'm going to take that plank sprite and put it in the Sprite Editor, and then just, we need it to be multiple sprite, so apply that, and then just automatically slice it and apply. And now we've got a plank, and it needs that rigid body 2D and that box collider as well. So physics 2D, rigid body 2D, and physics 2D, box collider 2D. So we're going to use multiple versions of this. We're going to build a house out of a bunch of them. We don't want to copy and paste these around too much unless we make them a prefab, because if you haven't dealt with prefabs before, they're very versatile. I'm only going to briefly cover that here, which is if you make a change to the prefab, it'll propagate to all of the instances of that prefab. So let's create a new folder called prefabs. And you can make this a prefab simply by dragging it into the prefabs folder, or any folder, just anywhere in your project directly, but I want it in the prefabs folder. And let's just call this plank. And I'm going to change this the name of the prefab as well. To build the house, you're going to have planks that are upright and planks that are horizontal. So horizontal planks and vertical planks. So I'm going to duplicate this one, and then I'm going to rotate it 90 degrees. So now I have sort of a palette of planks to choose from. Let's grab the first one and just sort of set it here on the ground and duplicate it and move this one over here. If I want to make sure they're on the exact same level, I can also use that V key, and I can snap it. I've snapped it to the neighbor, and then I can just grab it along the x-axis and move it out that way. Let's grab this horizontal plank, put that there. There we go. Then I'm going to grab these two, duplicate this, and move these over. V key. There we go. And then on this side, I'm going to do that again. Grab one, grab two, duplicate this, V key. There we go. And then grab three, duplicate this up, and then I'm just going to lift that up on the Y. There we go. So let's save this, back out a little bit, put our sky back in. Oh, none of our blanks. So here's a good example of what we can do with prefabs. I'm rushing a little bit because we're running late. There's our plank. All of our planks are on the default layer, and remember they need to be on the foreground layer. And notice that I've changed that prefab asset in my project window, and all of the instances are changed immediately. So now let's go ahead and save this. Let's go ahead and hit play. Let's see what happens. And I miss. Try that again. Boom. So you can see that the primary, scripting that we've done was on the rock in the previous episode. And now all we've had to do is put in physics objects that work within the Unity's physics system. And we haven't had to do any scripting at all for anything other than we've done the camera and we've done the rubber band, and everything else is just part of the built-in physics system. And it works fine. The last thing we need to do is destroy our target. Because our little target bird there is happily surviving as a physics object and isn't being harmed at all. So let's do one last bit of scripting. Let's grab our target and let's create a new script on the target. And let's call that target damage. So because we're going to damage the target with this particular script. Again, it's dropped in our root, so let's put that into the scripts folder and then double click it to open it up in MonoDevelop. So what do we need to do here? Let's get rid of the sample code. We're going to need to keep track of some things like hit points. So let's have a public int called hit points. And let's make that equal to 2. So it takes 2 hit points and then we kill it. When it's damaged, we want to change its sprite. So public sprite. Let's just call this damage sprite. Damage sprite. And a public float. Is it possible to use onCollisionEnter to destroy the bird? Yes, you can. We are going to do that, as a matter of fact. You've jumped the gun. So take a look at what we're doing here. So I'm just quickly grabbing some information that we will need. We're going to need a float, and that's going to be our damage impact speed. So our damage impact speed. How hard is he being hit? So that's how fast, either the asteroid hits it or how fast the planks fall on top of it. And then with our hit points, we can assign the total number of starting hit points, but we also need to keep track of, and it's good to be private, our current hit points. Current hit points. Let's quickly just lay out our float for our damage impact speed square. And lastly, reference to our sprite renderer, because this is so that we can change that sprite to the damage sprite, and we'll just call this sprite renderer. So in start, we need to go ahead and grab some of these things, like our sprite renderer is going to be equal to a get component, because it's going to be on this game object. So we want a sprite renderer here. And our current hit points, we want that to start off as our hit points, because we start that at the game, start off with 2, and our damage impact square is going to be equal to our damage impact speed times our damage impact speed. So we've set up our script, and we don't need update in this. What we want, and somebody called it out there on OnCollisionEnter, 2D. And again, we have to make sure that we get the 2D on that, onCollisionEnter 2D. And that's going to take as a parameter our collision 2D as well. And that's going to be our collision. Only if I can spell it, collision. So if, and we're going to need to set up some tags for this because we're going to be using tags in this case. So if our collision dot collider dot tag, so if our tag is not equal to damage, or what should we call this? Damager? Damager. How about damager? So if our tag is not equal to damager, then we simply want to return. And if the collision, its relative velocity dot square magnitude is less than our damage impact speed. Let me just copy that. So if our collision's relative velocity square magnitude is less than our damage impact speed square, then we also want to return. So if we're hit, if we've had some damage, I don't care how much damage it is, just 1 point at this point, we want to take our sprite renderer and say its sprite, the sprite that's being held by our sprite renderer is going to be equal to our damaged sprite. So we're going to just show that damaged image, and then we'll take our current hit points and do a minus minus. We'll just decrement it by 1. And then we say if our current hit points is less than or equal to 0, we'll kill the object. So that's our on collision enter. Now our kill function is going to simply take our sprite renderer and we're going to turn that off. So we're going to make this object invisible. And then we're going to take our collider 2D and also turn that off. And our rigid body 2D, we're going to make it kinematic. So we're basically turning off all of the physics and visible aspects of this particular game object. So let's save this and return to Unity and see if we can pass the compile test. Oh yes, we did. Awesome. So we've now got this damager on our target. Our damage impact speed, I don't know which way. We'll try it. I don't know what we should put in there. Try 1. Let's see what it's like. See if it works. Is that something we'll just have to tune for the game that we want it to be? But we also need to create a tag for damager and apply that to the things that could hit our target. First one are all these planks. So let's add a tag, and that first tag is going to be damager. If we're worried about it, we can copy this and we can paste this in and we know it'll be correct. Now remember, when we create a tag, we haven't assigned it. So we'll have to come back and we'll have to assign that tag. And the other thing that could possibly hit our bird is our asteroid. So that needs a damager as well. Otherwise, it would only be the planks that would go ahead and damage that. So let's save this. Let's hit play. The only thing we may have to tweak is that value of how often it, that might be 1, maybe a little bit low. We could crank that up. Let's see what happens if we gave it an impact of 5. But, you know, you can play with that yourself until you get this to react the way you want it to. Yeah. Something along those lines. You could use the game object that's set active false. And again, why in this particular project the author decided to make a kill function that turned off the components without turning off the game object? Well, there's one reason, and this is the last step. You could imagine a different way of doing this, what we're about to do, a different step. Let's add a particle system to this particular game object, that little puffy particle system. And I have it here on my desktop called Death Puff. And one of the ways to bring this in is to do assets, import package, custom package. And let's bring in off the desktop, let's bring in that Death Puff. Now when it comes in as a package, we're going to get, we can see there's the material, there's the prefab, and there's the image. So I'm just going to go ahead and import that. It will put things in existing folders if they exist, or it will add the folders as well if they don't. Well, there's Death Puff. Oop, there we go. But the architecture that the original author had is the particle system was a component on the target game object. But I have this prefab. How do I get it on without just rewriting it, looking at all of these details? Well, you can go up to any component and you can copy that component. And you can go to another game object, and then you can, using the cog menu, paste component as new. Boop. And we now have that particle system on this particular game object. Now we can get rid of that instance, because that particle system is here on our game object. So we need one more thing to change here, which is when we kill, and this is partly why I think they chose to do it this way, we can then say our particle system dot play. I would not have set it up this way, but this is perfectly legitimate. I have a tendency to instantiate particle system prefabs, but then you're getting into an instantiate and destroy situation, whereas in this particular case, the author has written it so that the particle system is hiding on the game object, and then we choose to play it. Let's save this. The one thing that we need to make sure is off, and I think it is, play and awake is off. So let's save this. Let's go ahead and hit play. All right, let's go ahead and see if that works. There we go. There's our puff. We'll zoom in so we can see the puff a little better on the scene view. And then we'll do a boom. There's our puff. And let's do a maximize on play. One last play, and that'll be the end of this session. We'll go into Q&A. Oh, we stopped moving. There's some finesse to this. You know, how long do you want to let things before you restart the game? There's some things that can make this a little bit nicer, but. Oh, we haven't assigned the other thing we haven't assigned our sprite, our damaged sprite. Oh, silly me. So there's our damaged sprite. Death sprite goes in there. Thank you. There we go. Got it. Ha! Rushing there towards the end. Okay, so well, that's the end of the lesson. We will move into Q&A, but before we do that, I just want to pop up our little message that we like to put up. So you can follow us, please. Follow us at Unity 3D. Follow us at Mike Geig. Follow us at Will Goldstone. And you can follow me at The Ant Ranch. You can also leave messages for us on the forum in the teaching section under live training. And you can give us comments, questions, suggestions, and let us know what you think.